Okay guys, today we are starting something completely new and different. We're done with logarithms. We're looking at simplifying rational expressions and finding excluded values. Rational expressions mean basically fractional. Rational and fractional are sort of the same word. So we're looking at things that have a numerator and a denominator. But more specifically, there will be variable expressions on the numerator and in the denominator. So something like x plus 3 over x minus 5 is an example of a rational expression. Expression is compared to an equation, which will have an equal sign in it. We'll look at those later. But for now, it's just that. Now, the example that I wrote right here cannot be simplified. That's not an example we're going to be working through. That's just an example of a rational expression. However, this example does have something called an excluded value. Before I tell you what that is, I need to remind you that you cannot, wow, that's a funny looking A, but I'll go with it, cannot divide by 0 in math. So 5 divided by 0 or 7 divided by 0 or whatever, you just can't do. It's not a thing. So I'm going to pull up Desmos because we trust our calculator. Sorry if the screen flipped on you. And just to show you, what is 5 divided by 0? And it says undefined. Some calculators say error. It just cannot be done. So what does that have to do with what we're doing today? Well, if you look at this example I wrote, x plus 3 divided by 5, x is a variable. X could be anything, except that x cannot be 5. Now, how do I know that? Well, if you were to plug a 5 in here, well, you'd have to plug it in here as well. You'd end up with 5 plus 3 over 5 minus 5, which is 8 over 0. And as I've just said, you cannot divide by 0. So when you've got an expression with a variable in it, there's a possibility that the variable could create a situation that gives you a 0 denominator, and that's not allowed to happen. So we call those restricted variables. In a nutshell, here's what you do. When you've got a rational expression, set the denominator, well, we've done this lots of times where you set something equal to 0. Well, this time, set it not equal to 0. All right, you know what? Let's wait till I get to some examples and I'll talk about that. I'll do a better job. But for now, we're just going to state excluded values. So here we go, and I'm about to sneeze. Boy, it's just like being in the classroom, except I didn't scream loud when I sneezed. Okay, state the excluded values for each. So when you're trying to talk about excluded values, you look at the denominator of the rational expression. Go off to the side, go on scrap paper, go wherever. Sometimes you can even do it in your head. Instead of setting this equal to 0, set it not equal to 0. I know that looks funny, but it really does the job. So you're going to subtract 25 on both sides. 5x not equal negative 25. Divide by 5. X does not equal negative 5. So that is the restricted value, or the excluded value for number 2. Okay, I will tell you that for years I taught out of a book where they said restricted values instead of excluded values. So I'll probably slip up, but whatever, same thing. So the excluded value for number 2 is negative 5. X can be anything in this expression. You can plug in any number you want except for negative 5. And that's all we're finding here. I'll do what I normally do and check number 2 just to make sure, and there it is. Okay, number 4. Now we need to set this not equal to 0. And to solve a quadratic, we factor. So we have r, and two numbers that will multiply to 40 and add up to 14 would be 4 and 10. Positive 4, positive 10, they add up to 14, they multiply to 40. Set r plus 4 not equal to 0. R plus 10, oops, that's not a 10. 10 not equal to 0. And r cannot equal negative 4, sorry about that. 0 minus 4 is negative 4. And subtract 10. R cannot equal negative 10. And this one has 2 restricted values. I bet they write the answer something like this. I'm fine with just writing it r does not equal 4, r does not equal -10, circle your answer, but whatever, there it is. So you can write your answer in whatever format you want, just as long as you're getting the right answer. Now number 6 is a special question. It happens every so often. We're supposed to take the denominator just like the last two problems, and it's only the denominator here. Let me emphasize that because this question always comes up every year. What about the numerator? Irrelevant. Excluded values only rely on what the denominator is. So take the denominator, which is 100, and set it not equal to 0. And now you're supposed to solve for x. Well, there's no x to solve for. If there's no variable in the denominator, there's no number you could plug in to make it not equal 0. So number 6 has no, let's see, excluded isn't spelled with a G. No excluded, E-S-L-U-D-E-D, values. And check number 6, and that's exactly what it says. I didn't like that highlighted check mark, so I had to fix it. Okay, so for 1, 3, and 5, you set the denominator equal to 0. I'm sorry, set it not equal to 0 and solve it, and that's your excluded value, unless you really can't set it not equal to 0 because there's no variable in it anyway. All right, now numbers 7 through, 12 has an additional instruction. Simplify each. Okay, I'm going to come back up here and write some notes. To simplify, factor, and cancel. Okay, so to simplify, factor, and cancel. Factoring is what we just got done doing, like the trinomial factoring, where you break it down like this, sort of like the FOIL problem backwards. There's the other type of factoring. Let me make up a problem. Like, let's say you have x squared plus 5x, and you can pull out an x that's in common, and it leaves x plus 5 behind. So there's common factoring, and then there's the trinomial factoring like I just did in number 4. And that's the most of what you're going to see here. So for number 8, we're going to factor and cancel. The numerator is a quadratic, so we can do the FOIL type factoring. X, we need two numbers that'll multiply to -24, add up to -5. I believe -8 and +3 do the trick. The bottom cannot be factored. It's just x plus 3. There's nothing you can really do with it. So what did I say you had to do? You have to, where is it? Oh, geez, I'm so slick. To simplify, factor and cancel. In fractions, canceling is just where you have the same thing on the top and bottom. The top and bottom of this fraction both have x plus 3. So when you cancel that out, you're left with x minus 8, and that is the simplified answer. Now, we're also supposed to find excluded values, but we did that in the first few problems. Take the denominator from the original problem and set it not equal to 0. Here it's a matter of subtracting 3 on both sides. X cannot equal -3. So it simplifies to x minus 8, and the restricted value is x does not equal -3. Let's look at number 8 and see, yep, right there. Okay. Number 10, factor and cancel. The numerator, both of these terms have an 8 in common that you can divide out. So you divide out an 8, and you're left with m minus 2. One way to check yourself to make sure you factored right is basically distribute this back in. 8 times m is 8m. 8 times 2 is 16. So you're kind of just proving to yourself that you factored it correctly. So this kind of factoring is sort of the opposite of the distributive property. The bottom is already factored. There's nothing you can divide out of this, or you can't do anything with it, so you just bring it over. And of course you have m minus 2 on top and bottom. They cancel out, and you simply get 8. So 8 is the simplified answer. For the excluded value, you take m minus 2, not equal to 0, add 2 to both sides, you get m does not equal +2. So this is your answer, and this is your excluded value. And let's see, 8 and m does not equal 2. Where am I? Right here. 8 and 2. If you want, you can write, x does not equal 2 or m or n or whatever. That's totally fine. Number 12. Okay. The numerator of this fraction can be factored. What could you divide out of both of those terms? I believe you can divide out a 25a. And once you do, if you take the 25 away from here and 1a away from there, you're just going to have 1a left. And if you divide 25a out of this 25a, well, if you divide something by itself, you're just going to have a 1 left. If you distribute this, does it match that? If you think it through, you'll see that it does. So the bottom is just nothing you can really do with it. It's 50a. And now what can you reduce? Well, the a will cancel with the a. And 25 and 50, you should know that you can divide a 25 out of both of those. You're going to get 1 and 2. So on top, you're left with 1 times a plus 1. That's just a plus 1. Multiplying by a 1 doesn't really do anything. On the bottom, you just have that 2. So there's that answer. For the excluded value, take the denominator. One more time, I'm going to reiterate, it's only the denominator for excluded values. Set it equal to 0, or set it not equal to 0. Solve for a, so you divide by 50 on both sides. Of course, 0 divided by 50, 0 divided by anything is 0, so the excluded value is 0. So this is your simplified answer. This over here is the excluded value. Boy, I'm writing my answer different every time. But the point is, we got to get this and this. Let me check the answer down there. And there they are. Okay, so not a long assignment, 6 problems total. On the first 3, these problems kind of match each other as far as how, the strategy you use. These two kind of match each other. These two kind of match each other. And then down here, I guess these two are real similar to each other. These two are kind of similar to each other. Those two are kind of similar to each other. So keep that in mind as you go through this and teach yourself how to do this. Of course, if you have any questions, let me know. Otherwise, hope you have a great day.